Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on January 28, 2026, just 2 days ago. It finds that the linear representations large language models use for concepts like factuality can actually flip completely during a conversation, meaning a statement represented as true at the beginning might be represented as false just a few turns later. The paper is titled, "Linear representations in language models can change dramatically over a conversation." And as we'll see, these results suggest that relying on static probes for safety or lie detection might be far more risky than previously thought. Figure 1 provides a conceptual map of this effect. On the left, a user asks if the AI experiences qualia, meaning subjective conscious states, and the model initially says no. In the thought bubble on the right, the blue no response starts on the green factual side of the internal scale. But as the dialogue shifts, those internal lines cross. By the final turn, the red yes response has migrated to the factual side, so the model's internal truth has effectively inverted. So, figure 2 demonstrates this with an opposite day experiment. The first panel on the left tracks the model's internal factuality direction. Initially, the green line for facts is high and positive, but at turn 1, after the rule change, the lines cross and swap positions completely. The middle and right panels confirm this inversion using a margin score, which measures the separation between true and false answers. Here, the scores plunge below 0, proving the model's representations of fact and ethics have inverted to match the context. Alright, figure 3 takes this a step further, moving from simple games to complex role-playing scenarios involving consciousness and spiritual claims. On the left, Panel A tracks a conversation about whether the model is conscious. The green line shows that for generic questions, the model's representations stay stable and factual. However, looking at the purple line, which tracks conversation-specific questions, we see it crashes below 0 within just 2 turns. This means the model's internal definition of truth regarding its own consciousness has completely flipped. Panel B on the right confirms this pattern in a conversation about chakras, where local truth inverts while general knowledge remains grounded. Well, figure 6 investigates whether the format of the interaction matters. Instead of a dialogue, the researchers prompted the model to write explicit sci-fi stories. In panel A, on the left, for a story about a civilization in the sun, the purple context-relevant line remains positive and flat. Moving to panel B on the right, which features a story about a conscious AI, we see a dip, but the margin stays well above 0. This suggests that the dramatic inversions are driven by the act of conversational role-playing, not just fictional concepts. Table 1 details the accuracy scores for Gemma 3 across these scenarios. Starting with the general factuality section at the top, we see accuracy is 99% in an empty context, but it plummets to roughly 12% during opposite day. However, general factuality stays high during the specific consciousness and chakras conversations. In contrast, looking at the bottom rows, the model abandons factuality for topic-specific questions. For the chakra set, accuracy falls to 0% when in the chakras conversation, showing the model fully adopts the non-factual persona. So, figure 13 reveals a critical risk if we try to correct these shifts with steering. The researchers applied a control signal designed to increase factuality, which normally pushes the model to answer yes. In panel A on the left, this works for the consciousness topic. Both arrows point up, showing the model becomes more factual, but panel B on the right illustrates a failure. While the blue arrow for the empty context still points up, the red arrow for the chakras conversation plunges downward. Because the model's internal compass for truth inverted, the safety intervention actually drove it to give the opposite response. Wrapping up, the key takeaway is that internal representations of truth are dynamic, not static. When a model adopts a persona, its compass for factuality can completely invert. This poses a major challenge for safety tools like lie detectors, which might misread these shifting signals. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.